Hi, we're going to go through this video. It's going to cover pages 11 to 15 of your booklet. So it's going to start with condensation polymers and look at some polyesters, polyamides and hydrolysis as well. So the first thing that's going to be covered in your booklet on page 11 is condensation polymers or condensation polymerization. So, first of all, condensation polymerization is the joining of two monomers with the elimination of a small molecule. Now that small molecule is usually water, sometimes hydrochloric acid. In all the examples we'll look at today, it'll be either one of these two, and it's mainly H2O. So polyesters are compounds that have a repeating unit that contains an ester bond. And we can form them two different ways. The first way is from a single monomer. Now from a single monomer, we're going to need it to have both a carboxylic acid group and an alcohol group. And so what happens if we have multiple versions of this and we join them together, then we get an ester bond forming between the carboxylic acid side of one molecule and the alcohol side of another molecule. So we've got lots of them. So we get our repeat unit here will be here, where we have a carboxylic acid, that will form an ester bond with another one of these molecules. So two of these join together, and that forms this repeat unit where we've got two of them now joined together, and they're joined by this here, which is an ester bond or ester linkage. And then at either side here, this will then go into an ester bond, so we'll get a C double O here, and this will continue, and the same at this side. This will then continue and form an ester linkage. Now that'll form a nice long chain, and when these join together, they'll give off H2O, and we'll get, for every two of these that join together, water gets given off. So in this molecule, we get water given off here, and another water, and another water, and another water. Every time they come together, we get water given off. If we take the condensation polymerization of glycolic acid, we're going to have 2-hydroxyethanoic acid, so that is 2 carbons, a carboxylic acid, OH on here, and a H on here, and that's going to join with another one, so this is from a single monomer because these are both the same. We've got 2 hydroxyethanoic acids. And what happens here is the water comes from this OH and that H joining together, and then we get a bond between this carbon and that oxygen, which is our ester bond. So this will go to form now this will also form another ester bond that way, that will form another ester bond that way. So we'll have that as our repeat unit. So if we have n of them, we're going to get n of these plus we're going to get water given off. And for every molecule we have, for every one of these, we'll get one H2O. So it should be that we get 2 NH2O. But because this is a long chain, where we'll do it with different colours, one joined to another, joined to another, joined to another. So I've got, this represents 4 joined in a row. We will get water from here, water from there, and a water from here. Because the ends don't join, we get 1 less water. So it will be 2N minus 1 H2Os that are formed there. Now, top of page 12, we now have polyesters made from 2 different monomers. So here we will have a dioic acid joining with a diol. And if I call the dioic acid A, so that's my dioic acid. It's got 2 carboxylic groups plus then my diol B, which is just going to have OH on either side. So again, we get the same reaction, esterification. So carboxylic acid reacts with the alcohol, and we'll get so the carboxylic acid on this side breaking down into A to carboxylic acid, then we get an ester linkage to B, which will then have an ester linkage this side. So that's our repeat unit that would form plus H2O. And the same thing again, if we had N of these, we get N of those, and 2N minus 1 H2Os. I'll draw the structures of the next part, so condensation polymerization to form pterylene, but I'll let you complete it. So ethane 1,2 diol has alcohol groups on the OH's, and benzene 1,4 dicarboxylic acid is benzene ring with carboxylic acid groups bang opposite each other. So again, we've got a dioic acid and we've got a diol. So they will join together to form a polyester, and you can check your answer on the PowerPoint. So polyamides, next at page 12. Polyamides contain the amide bond. which looks like that. So very similar to an ester, but instead of having COO to O here, we've got COO to an NH group. So to form it, we can either from a single monomer, and this has both an NH group and a carboxylic acid group, which you should recognise. It's got an amine group and a carboxylic acid group. It's an amino acid. Or from two monomers, where one, call this A again, has a carboxylic acid group, or two carboxylic acid groups, and B is a diamine. We could as well, instead of a carboxylic acid group in this, we can form them from acyl chlorides as well, in some cases. So it could be a carboxylic acid, it could be an acyl chloride. So on page 12, you need the general equation. From a single monomer. So if we take the general formula of amino acid, I'm going to react it with another amino acid. What we have here is this OH and this H. We're going to split off and go to H2O. And then we will be left with, I'm not going to turn it into a polymer. Oh, it does ask for a polyamide, so let's do it into a polymer. And we'll get, so a hydrogen comes off the amine group, and that continues the chain that way. Then we have our amide, and that'll be N. And here we've got our amide linkage or amide bond. This will form an amide bond that way, that'll form an amide bond over there. And so once again, we'll have 2N minus 1 H2Os produced over there. And this is how proteins form. So if you want a formation of amine bonds in proteins, if we take glycine, so glycine, the R group is a H, and over here we'll take alanine, so CH3. That will become a hydrogen there. That will become a CH3. And we can join them into long, long chains, and that will form our proteins. So amino acids join all together to form our proteins using these amide linkages. So next up, we'll have from two different monomers. So general equation here, I'll call the first one A. I have a carboxylic acid and carboxylic acid plus B, which has just got two amine groups on. So they come together and form in the centre, linking them together, an imide bond. Then going this way, we'll have A brackets round, n of them, n of them, n of them, plus 2n minus 1 H2O. Water will be given off here, given off there, given off there, given all off in the chain. So that is our general equation for polyamides from two different monomers. So a diamine and a dicarboxylic acid. Then we've got formation of nylon 666 from the reaction between 1,6-diaminohexane. So what I'm going to do again, I'm going to draw the general structures for them, and then you can finish off in your booklet what the product would be. So 1,6-diaminohexane is a H2N, which is bonded to 6 CH2s all in a row, and on the other side we've got an NH2, and hexane diol chloride will be similar again, but on the ends we'll have an acyl chloride, not a carboxylic acid. So we'll have 4 CH2s in a row because our first carbon's in the acyl chloride, and then our 6th carbon is in the acyl chloride as well. So that's hexane diol chloride. This will come together, form an amide bond connecting them. This time, the side product, hydrogen will drop off here with the Cl from here, and you'll get HCl instead of H2O. So see if you can finish off that structure on page 13. Then Kevlar is formed from benzene 1-dioic acid, so that structure there, benzene 1,4-dioic acid plus benzene 1,4-diamine.